Hi everyone, today we're going to learn the detail about ions, how ions are formed, what are the charges, and the symbol. We're going to connect that with the periodic table. Okay, a quick review. We did this last week. The octet rule. We have learned that every atom wants to have 8 valence electrons. That's why we call it octet. Octet means 8 or 4 valence electrons for the first few. They only need 2 to be in the most ultra energy level. Okay, for the first energy level, it only needs 2. Okay, so everything in the world want to be the most stable, the same as atoms. So we are going to look at the detail. How can they form 4 valence electrons? Okay. So to have 4 valence electrons, one choice is the atom can either gain or lose electrons. This normally happens during a chemical reaction. For example, this is lithium. It's number 3. It has 3 electrons, and one in the second energy level. Lithium would just prefer to give away this one. Okay, to lose this electron. Fluorine is number 9 in the periodic table. It has 9 electrons, and the second energy level has 7. It's easier for fluorine just gain one to have 8. Okay, so now let's look at which one would gain, which one would lose. Okay, let's look at this beautiful student drawing. I love this. It's exactly right. Very good job. And the group 1 has 1 valence electrons. All the elements in group 1 have 1 valence electrons. When it has 1, it's easy, very easy to give away. We're going to learn about the chemical reaction part and how easy they can be. They are very reactive. They can react quick, easily. Okay. And group 2 has 2 valence electrons. Again, they just want to give away the 2, become to have. For example, magnesium has 2 in the third energy level. It gave away the 2. It become 2 and 8. It's very stable. Okay, and group 3 has 3 valence electrons. Again, it's easier to lose all 3 compared to gain 5 more. Okay. Group 4 is a typical one. It has 4 valence electrons. It's not, it doesn't want to give those away, or it's not easy to give 4 away or gain 4. So carbon and silicon is a very special group. We're going to learn this next week. Okay, nitrogen group, oxygen group, and this is group 7. It has 5, 6, and 7 valence electrons. It would be easy to just gain 3, gain 2, and gain 1 to become to 8. Okay, once it has 8, the electron arrangements looks exactly like the last group in the periodic table, and they are the most stable. So here's the rule. Okay, valence electrons less or equal to 3, they would just lose those electrons to become too stable. Okay, valence electrons larger or equal to 5, like group 5, 6, and 7, they would just gain electron to become too stable. Okay, group 8 does not give away or lose those elements are very stable by themselves. Please write this part down. Okay, so now here's the concept. What does it mean by ion? We kind of introduced it last week. Ion is talking about a charged atom, which is formed by either gaining or losing electrons. As we know that the number of protons determine the element, and the number of protons would not change. Okay, so number of protons is not changing, but when we have gaining or losing electrons, that means the number of electrons would not equal to the protons anymore. So when they're not equal, positive and negative can cancel out, and the atom become to charge the atom. We call the charged atom an ion. Okay, here's the example for lithium. For lithium, it's number 3 in the periodic table. It means lithium have 3 protons and 3 electrons. The arrangement look like this, 2 and 1. Lithium would just prefer to give away this one. Once lithium gave away this one, it has 2 electrons left, but it still has 3 protons, 3 positive, 2 negative, can cancel out. You have one more positive. So the charge of lithium ion is positive 1. Normally, we write this ion as this, okay? The symbol and the charge and the number of charge. For 1, people normally don't bother to write it. Positive sign means positive 1, okay? And if you see positive 2, that means it's a positive 2 charge. If you see positive 3, that means positive 3 charge, okay? So now let's look at the other one, fluorine. Okay, fluorine is number 9 in the periodic table. It has 9 protons, always has 9 protons. Otherwise, it's not fluorine. Okay, and also normally it has 9 electrons. No, yeah, 9 electrons and 2 in the first energy level, 7 goes to the second energy level. It need one more to be stable. What's gonna happen is fluorine just need to gain 1. Okay, once they gain 1, it become to 10, and they have 10 electrons, negative 10, positive 9, negative 10. So you have one more negative compared to positive. The charge of ion, a fluorine ion, is negative 1. And again, we write the symbol and then write the charge on the top right corner. And when it's a negative 1, we don't bother to write the 1. Okay, and when it's negative 2, you're going to write 2 negative or negative 2 and negative 3. That's how we write the symbol. Okay, so we do give them special names. For positive ions, people call them cation. And negative ions, we call them anion. A easy way to remember is a cat has paws, positive, and the positive is cation. Okay, negative ion, we call them anion. Okay, how do we calculate the charge? It's basically number of protons subtract by number of electrons. When we have more protons, we are going to get a positive charge ion. When we have more electrons, you're going to use the protons minus a bigger number that give us a negative charge ion. Okay, and anion. Okay, so here let's look at the periodic table and let's find a pattern. Okay, so for number of valence electrons, we just learned it today. Group 1 has 1, group 2 has 2, group 3, group 4, 5, 6, 7, and 8. And as we introduced, these first few groups, 1, 2, and 3, just prefer to give away those valence electrons. It's easier to give away. Okay, when they gave away, they have more protons than electrons. They're going to form positive charge ion. And this one is a special one. Okay, this 5 and 6 and 7, they would just prefer to gain electrons. Once they gain electron, they become to negative. So here's the pattern. Okay, group 1 forms positive 1 charge ion. Group 2 forms positive 2 charge ion. Group 3 forms positive 3 charge ion. Group 4 don't form ions. Okay, group 5 negative 3, group 6 negative 2, group 7 negative 1, group 8 are very stable. They don't form ions. We are going to learn more tomorrow. Right now, we are going to just focus on ions. Okay, so I would say we're going to take notes on this page. And then I'm just going to show you some typical ions, very popular ones in the world. Okay, there's positive 1, positive 2, 3, and negative 3, negative 2, negative 1. Oxygen always from negative 2 charge. Okay, and sodium is positive 1 charge. Okay, so here, if you have a look of the periodic table, this region, this whole purple colored part, they are metals. Okay, and this region, the yellow one, they are non-metals except hydrogen. Okay, hydrogen is also a non-metal, but it forms positive 1 charge. All the non-metals tends to form negative charge. All the metals tends to form positive charge. Okay, here you may write this down. Metals always lose electron, give away. Metals are very generous. Here you go, take it. Lose electrons and form positive ions. We call them cations. And non-metals always gain electrons they receive, okay, and form negative ions. Please take those notes and watch the other video in the attachment. Thank you for watching.